Welcome to The Explainer. We hear the word serverless thrown around all the time, right? But what does it actually mean when we're talking about a database? Today, we're going to pop the hood and really look at the architecture that makes it all tick.
So, let's start with a really simple idea. What if your database worked just like a light switch? You flip it on, it's there instantly. You flip it off, and it's off. It's consuming absolutely nothing. This simple idea, it's really the heart of the whole serverless promise. It's a total shift in how we think about using resources. Now, to really get why that light switch thing is such a big deal, we got to look at a problem that has been a total nightmare for developers for, ever: capacity planning. It is just a frustrating, endless guessing game.
Yeah, it's this constant gamble, kind of like being on a seesaw. If you guess too high and over-provision, you're just lighting money on fire, paying for servers that are just sitting there, doing nothing. But if you guess too low, whoops, your app completely crashes the second you get a little bit of traffic. It really feels like a no-win situation, doesn't it?
Okay, so this is where serverless architecture comes in, promising a way out of that game. So what is it really? If we strip away all the marketing buzzwords, what are we left with?
At its core, it's a database that's delivered as a service. And look, the name serverless is, a little bit of a fib. Of course, there are still servers somewhere. The key is that you don't have to manage them. The provider, they handle all the messy operational stuff. That means you can just get back to what you want to be doing, building your application.
And this isn't just about one single feature. It's a whole new way of thinking, and it's built on a few core ideas. Just imagine, your database scales up and down automatically. You don't have to lift a finger. And get this, you only pay for the exact moments it's actually being used. I mean, that's the dream, right?
Okay, so how does all this magic actually work? Well, the secret sauce, the real genius, is in the architecture. Specifically, it's a concept called multi-tenancy. Now, just think of a tenant as a single user or a single application using the database.
See, the old way of doing things was all about single-tenant architecture. Your database cluster was like this big, isolated fortress, dedicated just to you. It was powerful, for sure, but also super rigid and really, really expensive.
So in that traditional model, you've got these two critical parts that are basically chained together. You have the SQL layer, that's the brain, the part that thinks about and processes your queries. And then you have the KV layer, that's kind of like the bookshelf where all the data is actually stored. By locking them together on the same machine, you create this massive bottleneck. This tight coupling, that's the root of the whole problem.
And so the key innovation, the real aha moment for serverless, was figuring out how to split these two layers apart, to decouple them. This one simple idea, it just unlocks incredible efficiency and flexibility.
And here's what that looks like. In a multi-tenant design, every user gets their own separate, isolated brain, their own SQL process. But, and this is the clever part, they all share the same huge, efficient bookshelf, that shared storage layer. This is how you can run thousands of tiny databases super efficiently on the exact same hardware.
The source material we're looking at puts it perfectly. It says this separation gives you the best of both worlds. You get that rock-solid security of having your own isolated compute, but you don't have to give up the cost-saving efficiency of sharing resources. It's pretty brilliant. And this new architecture, it leads to a truly staggering difference in speed. I mean, look at these numbers. Because the storage is already up and running and shared, creating a new database isn't about building a whole new fortress from scratch anymore. Nope. It's just about firing up a new lightweight SQL brain. And that, my friends, is the difference between waiting half an hour and waiting just a couple of seconds. It's a total game changer.
All right, so the architecture is really clever. We get it. But how does it actually handle the pure chaos of real-world traffic? This is where the rubber really meets the road.
So let's imagine your app just goes viral. I mean, boom, 1 million new users show up in an hour. What is actually happening inside the database at that moment?
Well, the system responds instantly. It starts stamping out these new compute instances, you can think of them as little worker pods, from a pool that's already warmed up and ready to go. Because they're already waiting in the wings, the database can absorb that massive, unexpected traffic spike in just a few seconds, without even breaking a sweat.
Okay, but what about the flip side? That's just as important. What happens when all that traffic just vanishes, in the middle of the night when everyone's asleep?
And here's where we finally get to flip that light switch off. As the traffic drops to zero, the system scales back down. And eventually, the tenant gets suspended. What does that mean? It means its compute pods are shut down completely. They consume zero resources. You pay absolutely nothing. But, and this is crucial, your data is always safe and sound in that shared storage layer, ready for the moment you need to flip that switch back on.
So now we get to the really practical part. We understand how it works, but when should you actually use this thing? Let's open up the serverless playbook.
So, when is this the right tool for the job? Well, it's a perfect fit for any app with that spiky, unpredictable traffic we talked about. It's also a total game changer for startups or small teams who'd much rather spend their time building cool features instead of managing infrastructure. And for all you folks with side projects or prototypes, it's unbeatable. You can get started in seconds, and often for free.
But, and this is important, it's not a silver bullet. It's not for everything. If you've got super high security workloads where sharing any resources is a complete non-starter because of regulations or company policy, then a dedicated cluster is still going to be your best bet. Same goes if you need absolute granular control over the physical hardware itself.
So let's wrap this up by thinking about just how big of a deal this is. The source material argues this isn't just some small incremental improvement. No, they see it as a true paradigm shift, something on the same level as the invention of the relational database back in the 70s or the internet in the 90s. It's a whole new foundation for how we build stuff.
Ultimately, this is all about moving away from that old, frustrating guessing game of capacity planning and moving towards systems that can react instantly to what's happening in the real world. And that leaves us with one final question to think about. Is your next project going to be built for the past, or is it engineered for the future?